Okay, what we're going to look at with this problem is where you've been given a series of information of data, a bunch of points on a line, and it's basically showing a graph between catalogs and sales. And so what they want us to look at is kind of the limit as we are approaching a specific point. So they give us all this information, and they just ask us to find the average rate of change of sales with respect to the number of catalogs distributed for the change in X. So catalog sales are going to be on the right, and the number of catalogs are going to be along the bottom. So here's your number of catalogs, here's your catalog sales. So basically what we want to do is we want to go from 10,000 catalogs to 30,000 catalogs, and we just want to connect those two lines, those 2 points with a line. So it's going to look something like this. Let me see if I can line it up just a little bit here. And what we want to do is we just want to find what the slope of that line is, okay? And it's really easy. It's the slope that we've done since time immortal. It's going to be y2 minus y1 over x2 minus x1. You've done the slope formula thousands of times up to this point. We're putting it into the calculus now, so basically we just need those 2 points. So 10, 40, the y-coordinate is 40, and 30, 60, the y-coordinate is 60. So we're going to do the second y-coordinate, your stop, minus the first y-coordinate, your start, over stop at 30, minus the start at 10. And we're going to do this math right here. And lo and behold, the average rate of change is 1. 1 what? We're looking at 1,000 catalogs. Let's see here. 1,000 catalogs per $1,000 in sales. So because we're talking about in thousands. So 1,000 catalogs per sale. And that's your rate in change. All right, so what we're going to do with this problem is we're going to check out the slope of a curve, and not just the slope of a curve, but a slope of a curve at a specific value of x. And in order to do this, we're going to have to rely on our good old limit rule, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. So in order to do this, we need a couple things. Number one, we need our function at x, negative 8, plus h. We need to know what that equals. All right, now we're going to do the slope of a normal line at an indicated point. And we have to take all the same steps we took on question number 23. We have to take all the exact same steps. But now, when we get done, we're going to look at the opposite reciprocal of that slope. And once we find the opposite reciprocal, we're going to have the slope, and if you'll notice, we've already got a point. So we'll have a slope and a point to write the equation of a normal line. So here's my point right here that they're giving me, x and y. I'm going to use my limit process again. So I'm looking at the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, the last question we've got on our review deals with trying to find horizontal tangents, and that can be really tricky, but remember that if you're working with a horizontal tangent, you're talking about a line that's straight, it's horizontal, which means that its slope is 0. So once I have the equation to find the slope, which means that I have to use the limit process, then I just set that limit equal to 0. So what does that look like? Well, I'm going to take my limit process, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. And whenever I get this done, I'm going to set it equal to 0, because remember, this whole thing is a slope. That whole thing is a slope. So when I get done, I'm going to set this equal to 0. What does that mean? That means that I need f of x plus h. So everywhere I see x, I put x plus h in. And so 6 times x squared plus 2xh plus h squared plus 5x plus h minus 1, which is 6x squared plus 12xh plus 6h squared plus all this other stuff. All right. Does anything go together here? Doesn't look like it. The other really key important piece of information is f of x. We don't have a specific point this time. That's what we're trying to find. So my f of x part is just the function. So how does my limit look? Looks like this.